Hello, I'm Dr. Aidoo with the Department of Anatomy and Cell Biology, School of Medical Sciences, University of Cape Coast. I present to you Histology of the male reproductive system. Now, this is to just introduce you to what the world usually demands. This is one of the laws from the book, The Laws of Power by Robert Greene. So, law 1 says, never outshine your master. Always make those above you feel comfortably superior. In your desire to please or impress them, do not go too far in displaying your talents, or you might accomplish the opposite. That is, inspire fear and insecurity in those above you. So make your masters appear more brilliant than they are, and you will attain the heights of power. Thank you. So regarding the male reproductive system, you will look at the sperm production in the testis, i.e. spermatogenesis, which comprises of meiosis and then spermiogenesis. You look at Sertoli cells, which are for support, and then Leydig cells, which is the source of testosterone and its effect on the male reproductive system. Hormonal regulation of the male reproductive system, the effect of testosterone and pituitary hormones. We will not go into my details because most of these LH and FSH have pronounced effect on the female, even though they also have some slight, functions in the male reproductive system. Then we look at the tract, which means the tubular or duct system of the male reproductive system. And obviously, this tract is where the sperms are going to pass through to their destination. So passage of sperm to the sites of fertilization. So this is a vertical section through the male reproductive system. So we can look at the structures involved here. The testis is shown here. That is the penis with the urethra within it. So all the way from the bladder through the prostate. So that will become the prostatic urethra. Then it goes through the bulbous region of the penis, and that will be the bulbous urethra. Then you have the penile urethra within the penis itself, the external portion there. Then you have this region, which is the glans penis. You can also trace some of the ducts all the way through there. All right, so you actually have to start from this testis and then go along that path, okay, and then it is voided out as semen. In the testis, you have about 250 lobules containing 1 to 4 seminiferous tubules. The seminiferous tubules contain these cells, 3 major cells. So note that you have the germ cells, which are also the spermatogonia, which will develop into the sperm. You have Sertoli cells, which are somatic cells. They are for support, nutrition, hormone receptors, among others. The boundary layer, which will contain the myoid cells or the flattened peritubular cells. So when we take a vertical section through the testis and some of the tubules, this is what you find. So you have this whole section containing most of the seminiferous tubules. But this is also significant, the tunica abogenia, which separates the primitive sex cords, which will later become the medullary cords, from the epithelium of the gonadal ridge. So that is that. So you have these portions also connecting to the seminiferous tubules. These are the straight tubules. You can't see them very well in this diagram. Then you have the rete testis. So this region is the mediastinum of the testis. And you have the efferent duct, and then the epididymis, and then the vas deferens. All right. So mediastinum of the testis will contain straight tubules and rete testis, as I've said. So straight tubules and then rete testis are here. And like I said, the straight tubule has been labeled, but you can hardly see it in this. Then you have the efferent duct passageway from testis to epididymis. So that is efferent duct passageway of the spermatozoa now, which will become actually spermatids, from the testis here to the epididymis. Okay, so that is going to allow the spermatids, which actually came as a result of the development of the spermatogonia, into the sperm. Epididymis contains head, body, tail, which is this region. So that's the tail, that is the head, and that is the body. Ejaculation, ductus deferens conducts sperm from epididymal tail, so from here all the way, ductus deferens. Seminal vesicles usually furnish most of the seminal fluid. Prostate gland contributes to seminal fluid as well. Semen passes through prostatic and penile urethra. So this will help us to appreciate the whole journey. So these are the lobes. So we have one lobe there, another one there, this, that. And they contain the seminiferous tubules. Now you can see the straight tubule very, very clearly here. Straight tubules, which will connect the rete testis. And that's the efferent duct. And that is the epididymis. Okay. Remember that the efferent duct and epididymis come from a common source. Okay. So you should remember that. The mesonephric duct. That's the tunica abogenia. So this is what histologists like. This very nice pattern. So this is testis at low power containing seminiferous tubules. So this is how a seminiferous tubules will look like. All those black dots are cells. Okay, at different stages. So spermatogonia, either dark or pale. Then primary spermatocytes, secondary spermatocytes, spermatids are all in succession in each of the cross sections you see. Okay. So when we take just one of the tubules and go through it, this is what you are going to find. So that's the boundary layer, which will contain those flattened or myoid cells. Then we are going to journey from the boundary all the way towards the lumen there. So you can see all these are cells. Different cells at different stages, and they mature towards the lumen. So these are Sertoli cells. And then as you move deep, you have some of the primary spermatocytes also at this point getting close to the lumen, so which will obviously migrate or develop into secondary spermatocytes before they become spermatids like that. Okay, so these are actually spermatids which have some angular or oval shaped heads. As a very young spermatid is also a spermatid. Okay, this is likely to be a secondary spermatocyte, and that will also be secondary spermatocytes. So at this base, you are going to have these ones to be the spermatogonia. They are in touch with the base. Okay, so these ones will be the spermatogonia, and depending on whether they look dark or pale, you can tell whether it is an A type, A pale, or A dark. So when you even compare this to that, you realize that this is looking darker than this. Okay, this also looks dark. These ones are obviously Sertoli cells, which also look star-shaped or triangular. So this will also be another stage of development. So that is primary spermatocyte, and obviously all these will be the spermatogonia, which are very close to the base. So this will also be a primary spermatocyte, another one there, another one there. You can now see a secondary spermatocyte. And then you also have spermatid. This is very early stage. The late stages will have the oval shape, right? So you can even see one undergoing some cell division. So that is how this looks like. This is also another compartment of a different, seminiferous tubule. So in that case, this will also be the boundary layer for that one. Okay, with all these cells in succession going deep into the lumen. So at a lower power relative to what we just saw, this is going to be an outline of one seminiferous tubule. That's the lumen. That will be the boundary layer with the myoid cells, the flattened cells. So this will be another seminiferous tubule. There's another one there, another one there, and then another one here. There's another one there too. So the interstitial region here is containing one Leydig cell. Okay, so remember, Leydig cells are not found within the seminiferous tubule. It's rather Sertoli cells that you find the seminiferous tubule. Okay, so it means that the mature cells will be closer to the lumen. That will be more of the spermatid. So there are tails that are available or prominent are actually found within the lumen. So you can now see very beautiful, tail-like filaments, okay, thread-like structures. All these are the tails of spermatid. So you can see that's a spermatid with an oval-shaped head. There's another one. All these regions will contain spermatids. Then you have secondary spermatocytes. Then you have primary spermatocytes, and then you have spermatogonia, okay, dark and pale type. Then obviously the Sertoli cells will also be there. Then you expect to find Leydig cells in the interstitium. So the Sertoli cells basically support and nourish the developing sperm. All germ cells are surrounded by Sertoli processes or lie in Sertoli surface invagination. So when you look at this, this is one Sertoli cell, okay, extend from the boundary all the way to the lumen. And you can see that it has trapped some of the Sertoli cells. Okay, and in fact, within them too, we are going to have some of the early, developing spermatogonia there. So this will now form a boundary with another Sertoli cell. So you can see here, to record that the tight junctions, Sertoli tight junctions, which will actually help block the entrance of extraneous proteins into the seminiferous tubules. Okay, so anything that has to get to the sperms have to actually pass through the Sertoli cells. So the Sertoli cells will check. Okay, so you can't just come and then have any involvement with the developing sperm. Yeah, so this is to prevent antigen antibody reactions, because sperm will arise around puberty, by which time the immune system is already set. Okay, so any new thing that will come might be seen as foreign, and then the body will fight against it. So the Sertoli cells tries to protect these developing sperms, okay, from these immune system. So sperm surface antigens may be seen as foreign if they are not protected. This is an example of a Leydig cell. They produce testosterone. Okay. So actions of androgen, like the testosterone on the seminiferous tubule. So testosterone is the main hormone regulating spermatogenesis. It acts on Sertoli cells, which have the androgen receptors. On the male reproductive tract, these androgens also regulate development and maintenance of the tract, the male tract. So when we say the tract, we are talking of the tubules with the lumen, dihydrotestosterone. On the secondary sexual characteristics, androgens help regulate muscle tone and strength, lower the voice, and therefore becomes deep. Axillary and pubic hairs are also regulated by that. Beard and dense body hair, and then sometimes even acne on the faces of the teenagers, if you like. Receding hairline and baldness also occurs because of the testosterone effect. So mostly males, as they grow, their hairline, draws backwards or recedes and then ends in baldness. Pituitary regulation of the male reproductive. So luteinizing hormone, LH, regulates androgen secretion by the Leydig cells. The androgen also regulates spermatogenesis, and therefore the male tract secondary sexual characteristics, which we have covered just in the previous slide, concerning the deep voice, the hair on the chest, and then beard, and the like. LH receptors are on the plasma membrane of Leydig cells. Follicle stimulating hormone, FSH, also regulates the establishment of spermatogenesis at puberty. The receptors are on the plasma membrane at the basal surface of the Sertoli cells. Remember, we said Sertoli cells start from the base and then get to the lumen. So the basal side, that is where you find the receptor for FSH. Although Sertoli cells in the mature testis have FSH receptors that probably have some functions, FSH does not appear to be essential for spermatogenesis in the adult testis. But we know that FSH plays very crucial roles in the development of the follicles within the ovary of the female reproductive system. Now, to prove that pituitary has effects on the development of the sperm and therefore the duct system, this is a micrograph from the testis of a rat with the pituitary removed. Okay, but this one is the testis of a rat with the pituitary intact. So you can tell that most of the nuclei or the cells are not developing well, Okay, most of them are undergoing degeneration compared to the one that has the pituitary intact. Very beautiful succession of development from the base all the way towards the lumen. So the germ cells are healthy and growing very well. The mediastinum we mentioned contains straight tubules, red testis. So this is how the straight tubule will look like. Obviously, all these are seminiferous tubules, okay, with different stages of development of the sperm. That is the red testis. Appreciate its unique appearance. This is the efferent duct and then epididymis. So efferent duct has its lumen lined by undulating epithelium. Okay, so you can see that it's not a smooth running epithelium compared to the epididymis, which is so smooth and then continuous, very almost straight running. Okay, so that's how you can differentiate between the epididymis and then the efferent duct. So this at a high power of an efferent duct, you can now appreciate the undulating nature of the epithelium. That's the lumen. Those are smooth muscle cells. Cilia, cilia are also coming from the spermatids, the tails of the spermatids, which are developing into sperms, which are now maturing. So that's the basal cell. So that's the epididymis. This is the vas deferens with a lot of muscle there. Remember, this one looks like a portion of the oviduct of the female reproductive system as you get closer to the uterus. So like the isthmus region. So you have to be careful how to differentiate between them. So semen is usually 3.5 ml per ejaculate, and within that, you expect to have about 100 million sperm per male. So you can calculate if 1 ml gives you 100 million, then 3.5 ml will give you how many? So the concentration is such that if it is lower than 20 million per ml, then it's likely to cause infertility in males. Seminal fluid are usually contributed by the seminal vesicle and then the prostate. This is how the seminal vesicle also looks like. Very, very unique. Very, very unique and beautiful as well. For the prostate gland, it is covered by a connective tissue capsule which forms septi penetrating the parenchyma. It is composed of fibromuscular and glandular tissue. Three groups of glands are usually epitomized here. You have the mucosa, submucosa, and then the main. You have different names for these regions as we go on. So this is more like a concentric kind of arrangement. What are the cells present in the prostate gland? You have basal cells, you have smooth muscle cells, fibroelastic tissue cells, blood vessels, lymphatic vessels, nerves. Prostatic concretions may be present depending on the age, what we call the corpora amyloacea. The epithelium is lined by simple columnar or pseudostratified columnar or low cuboidal or simple squamous or transitional epithelium. So a myriad of epithelial characteristics there. So if you want to trace the mucosa, submucosa, and the vein, we can use these numbers 1, 2, and 3. We expect mucosa, by convention to be very close to a lumen. Okay, so mucosa, then submucosa, deeper, and then you have the periphery being the main region. Okay, so the prostate gland contains the three major glandular regions from outward within, or what we term without inwards, which means you are traveling from outside and getting towards the middle portion. You meet the main zone, which is also called the peripheral zone, followed by the submucosal median zone, also known as the central zone. Then you also have the mucosa or urethral zone. We also term the transition zone. So the peripheral zone is the largest. Okay, peripheral, the main zone, covers about 70% of the prostate volume. The central zone is relatively resistant to carcinoma and other diseases. However, the transition zone is the main site of prostate hyperplasia. Okay. Then if you want to go through the same zones but coming from inside going outward, you are going to have the transition zone first. That's the mucosal zone around which the within which the urethra, prostatic urethra will pass. Okay, so that is the urethral zone. The transition zone is the main site of origin of prostate hyperplasia. The central zone will follow, and then peripheral zone. So it's just like you are running opposite direction compared to that. So this is a very simplified, diagram showing you the regions we have described. So this is the urethra. So around it, you have the mucosa or transitional zone. Then this region within which you have the ejaculatory duct will be the central zone or the submucosa region. And then this area becomes the main zone or peripheral zone, which we said contains about 70% of the volume of the prostate. Then very anteriorly, you have this small region, anterior fibromuscular zone. So these are the corpora myelacea, the concretions that you find in aged prostates. Okay. Some believe that they are the residue of, waste substances that are formed within the prostate, byproducts, for want of a better word, become concretions like that. Okay. So that is the prostatic urethra. So you expect that the mucosal region will be around that. Then you have the submucosa, and then you have the main or peripheral zone. Okay. So adult prostate gland cross-section low power LM, there are about 30 to 50 compound tubulo-alveolar glands. So this is describing the type of gland you find there, compound tubulo-alveolar. The secretion is expelled into the semen during ejaculation. They contain acid phosphatase, citric acid, fibronolizin, and then prostate-specific antigens. All these are used for testing to know the state of the prostate. So you may have benign prostatic hypertrophy, BPH, nodular hyperplasia. It's common in men over 50 years of age. It occurs primarily in the submucosa and mucosal glands, sometimes causing urethral obstruction. You may also have this leading into cancer. So prostatic cancer or carcinoma is the second most frequent cause of death from cancer in the US. Carcinomas occur primarily in the main or peripheral glands. That's an example of the prostatic concretion. It's a glandular acina, because they are spherical, smooth muscle are also here. You can see the fusiform nature of the nuclei. Then there's the ejaculatory duct, prostatic secretion, fibromuscular stroma. So these are smooth muscles. That is the gland. That's also a gland, and that. Again, this is a gland, that is a gland. Then you have some smooth muscles there. That's a corpora myelacea. And that is a cross-section of the penis. So you have the corpus spongiosum or corpus cavernosum of the urethra, and then you have the corpora cavernosa. That is the superficial dorsal vein, deep vein. Then you also have the deep artery there. You have helicin arteries also there. And then the tunica albuginea is represented. The penis can be flaccid or erect depending on which vein or artery is being restricted or which is constricted or dilated. Okay, so restricted arteries, open veins will become flaccid. Erect means open arteries, restricted veins, so that you don't allow blood to flow back. Thank you very much.